Welcome back, everyone. Today, for our deep dive, we're journeying into the lush, green world of the Australian rainforest, Queensland specifically.
hmm
And we're looking at a plant that is, well, frankly, full of contradictions. It looks quite lovely, actually. Plush, almost fuzzy, with these big heart-shaped leaves.
Deceptively inviting, yeah.
Eh,
But it comes with possibly the darkest nickname in the entire plant kingdom,
hmm,
the suicide plant.
exactly. And that name alone tells you there's a story here. We're talking about Dendrocnide moroide, more commonly known as the Gympie Gympie.
And the contradiction isn't just visual. This isn't your garden variety nettle sting that, annoys you for an hour.
Not even close. The sources we've looked at compare the sensation to being burned with hot acid and electrocuted at the same time.
Yeah, it's an extreme comparison, but it seems warranted. Think about the Schmidt pain index for insect stings. Bullet ant sting is famously excruciating, right? The top of the scale.
Right, I've heard about that one. Unbearable pain.
Well, the Gympie sting apparently delivers pain right up there on that same level of intensity. But here's the kicker.
Uh-oh.
The bullet ant pain, horrible as it is, generally lasts about 24 hours. The Gympie Gympie, that pain can hit you instantly, like a bomb going off, and then just linger for months, sometimes even years.
Years from a plant sting. That's almost unbelievable.
It's a really profound mechanism of agony. And we've gathered these accounts that detail not just the physical torment, but the psychological toll it takes.
So today we're going to unpack all of that. We'll get into the anatomy of how it causes such pain, the frankly brutal ways people try to treat it.
And in a twist you probably won't see coming, how this biological weapon might actually hold a key to developing new kinds of non-addictive pain relief.
Okay, let's start with just how bad this pain is. The anecdotes are chilling. We found one account from a woman who said the sting was worse than going through 3 C-sections and 1 natural childbirth combined.
Wow, that puts it into perspective. And that level of agony triggers, a massive systemic reaction.
Yeah.
Often, it starts with just uncontrollable vomiting. Your body is completely overwhelmed.
That's total system shock.
Exactly. It's a world of pain that just shuts down everything else. And it all comes back to that seemingly harmless, plush look. It's in the Urticaceae family, same as common nettles, but it's like the superpowered nightmare version.
So the soft-looking hairs all over the leaves and stem, they're the delivery system.
They are the delivery system. They're structured like incredibly fine, densely packed hypodermic needles. But here's a really important detail. They're made of silica,
Silica.
like glass.
Essentially, yes, silicon dioxide. Think of them as microscopic, extremely brittle glass splinters. And they're loaded with venom.
Okay, wait. You said venom. We usually talk about venom with snakes, spiders, things that actively inject. Does calling it venom change how we think about this plant?
It's a really crucial distinction, actually. Most toxic plants are just poisonous.
Yeah.
You have to eat them or absorb the toxins somehow.
Right. The Gympie is different, those silica hairs. They are specifically designed to break off in the skin, to penetrate, and actively inject these potent neurotoxins. Scientists call them Gympietides. It's a true venom delivery system, just like an animal's fang or stinger.
Gympietides. Okay, so these neurotoxins, what do they actually do to your nerves to cause such long-lasting agony?
This is where it gets both fascinating and terrifying from a biological standpoint. Unlike toxins that just cause, say, inflammation, Gympietides seem to directly target something called voltage-gated sodium channels in your nerve cells.
Okay, what does that mean in simple terms?
It means they basically jam the on switch for pain signals. They force these channels to stay open, making the nerve cell fire pain signals constantly, relentlessly, to the brain, even when the initial trigger is gone.
So the plant's toxin essentially hacks your nervous system's hardware, forcing it to scream in pain long after you've touched it.
You got it. And the toxin itself is incredibly stable. This is wild. Researchers have tested dried Gympie samples collected like over 100 years ago. Still potent. If you touch those century-old dried leaves, they can still cause that excruciating pain. The chemical structure of Gympietides just doesn't break down easily.
That is remarkable and horrifying. And as if touching it wasn't bad enough, you don't even need direct contact.
No, and this is the really insidious part. The plant constantly sheds these microscopic, toxin-filled silica hairs. They're so light they just float in the air around it.
Like an invisible cloud of pain needles.
Pretty much. So just standing too close, breathing the air near the plant for a while, you can end up with agonizing, nonstop sneezing fits, nosebleeds, respiratory irritation. Those tiny glass needles get into your airways, your mucous membranes. It's a non-contact hazard.
What an absolutely terrifying defense mechanism. Okay, so you get stung. What happens immediately, systemically?
Well, the pain is instant, but it actually peaks about 20 to 30 minutes later. And in that window, something else kicks in. Your lymph nodes near the sting site, they go into overdrive, aggressively swelling. And they often start throbbing with intense pain themselves, sometimes for hours. So it adds this whole other layer of agony on top of the initial site. It quickly becomes a full-body crisis.
Which brings us to the treatment, which sounds medieval is the only word that comes to mind. The absolute first rule, apparently, is never rub the area. Why?
Because those silica hairs are so incredibly fragile. If you rub, you'll just break them off right at the skin level or even below it. Makes them impossible to get out. They just embed deeper.
So you've got these microscopic glass needles stuck in you, pumping out neurotoxin. How on earth do you get them out?
The recommended method is, it's harsh. It has to be, because removing the source of the pain is critical. Step 1 involves splashing the area with dilute hydrochloric acid.
Hydrochloric acid onto broken skin.
Dilute, very dilute. The idea isn't to burn you further. It's supposedly to break down the peptide coating on the hairs.
Yeah.
Maybe neutralizing some of the venom load before you try to remove them.
Okay, but still, acid. Is there solid proof this works better than, I don't know, just flushing with loads of water?
That's the thing. Water is actually a terrible idea, which we'll get to. The acid step. It's kind of a desperate measure, born from experience, I think. Because immediately after the acid wash,
What comes next?
you apply wax strips, like hair removal wax strips.
Yeah.
And you rip them off, hoping to pull out as many of those embedded silica hairs as possible. It's been likened to an emergency Brazilian.
Oh my God. So you're waxing broken, acid-washed skin to pull out glass splinters.
Yeah, because your body simply cannot break down silica. Any hairs left behind, they can stay there forever in some cases, constantly triggering pain.
Which leads to that final, truly cruel twist you mentioned. The water trap. You're in agony, your instinct is to use cool water, wash it.
And you absolutely must not. Water seems to somehow reactivate the toxins, or maybe change the osmotic pressure around the embedded hairs. The exact mechanism isn't fully clear.
But the result is?
The result is that for months, or even years later, taking a shower, getting caught in the rain, even just sweating heavily can trigger sudden, new, intense waves of that original agonizing pain, flashback pain. It's like the plant haunts you.
Unbelievable. Given all this, that nickname, the suicide plant, we need to address the lethality directly. Is the venom actually deadly?
Technically, no. It's not like, say, certain snake venoms that cause massive tissue death or organ failure. The Gympietides cause pain, extreme pain, but they don't directly kill tissue. Physically, you'll likely recover eventually.
But the psychological impact.
That's where the name comes from. The sheer, unrelenting, inescapable nature of the pain. It can clearly overwhelm a person's mental state. The excruciation itself becomes the danger.
And there are historical accounts that really drive that home.
There are. That first report from 1866 about the surveyor's horse that got stung, went completely mad, and died within hours. That paints a picture.
And the human stories.
The story, maybe apocryphal, of the WWII servicemen who supposedly used the leaves as toilet paper. The implication is the resulting trauma led to suicide. And then there's the documented case of a man who went, quote, mad as a cut snake after a sting, had to be physically restrained in a hospital bed for 3 weeks. These aren't just stings, they're potentially psyche-shattering events.
So it really forces the question. If this plant is such a biological horror show, how does anything live with it? How does the Australian ecosystem cope?
Right, and this is where evolution shows its incredible power of adaptation. Because despite this terrifying defense, some native creatures have figured it out. They've evolved ways to tolerate it, or even use it to their advantage.
Like finding a safe zone in a dangerous place.
Exactly that. We see insects, like certain mantises and spiders, actually using the deadly venom-coated leaves as shelter. They hang out there knowing most predators won't dare come after them on those surfaces.
Smart. What else?
There's the Jezebel butterfly caterpillar. It's already covered in spikes itself, and it happily munches on Gympie Gympie leaves. Seems to have evolved complete immunity to the venom.
Wow. And birds.
Birds eat the fruit. It looks a bit like a raspberry, apparently also covered in those stinging hairs, but they eat it anyway and spread the seeds.
Okay, but the champion, the one that really defies belief.
That has to be the red-legged patamelon.
Oh.
This is a small marsupial, looks like a tiny wallaby or kangaroo.
A patamelon, and what does it do?
It eats the Gympie Gympie.
Yeah.
Like really eats it. Observers have seen patamelons strip entire plants bare of their leaves overnight. Leaves that could hospitalize a human for days or weeks.
They just eat it like lettuce, with no ill effects.
Apparently so. It's an incredible display of evolutionary adaptation. Complete tolerance to one of the most painful substances known in nature.
That level of immunity is just staggering. Which brings us full circle back to that final paradox. The idea that this plant, this source of unimaginable non-lethal agony, might actually hold the key to relieving chronic pain.
It sounds crazy, but that's exactly the direction the research is heading. Scientists figured out that those Gympietides work by targeting those very specific voltage-gated sodium channels in nerves, the ones that transmit pain signals.
So the thinking is, if they target pain so specifically, maybe they can be modified.
Exactly. The aha moment was realizing that if this toxin is so hyper-focused on the pain pathway, maybe it could be engineered not to cause pain, but to selectively block it.
A targeted nerve block derived from the thing that causes the worst pain.
Precisely. Researchers are actively exploring Gympietides as a potential basis for a whole new class of pain reliever. Because it's so specific, the hope is it could be non-addictive, unlike opioids, which have much broader effects. A non-opioid solution from the world's most painful plant. The irony is just immense.
What an incredible journey. From the suicide plant nickname, the horror stories, the acid and wax treatment, to finding insects sheltering on it, patamelons devouring it, and now maybe a future without opioid dependency.
It really highlights how evolution, under pressure, can produce these incredibly potent, sometimes terrifying chemical innovations, but also potentially solutions we'd never expect.
Understanding this gives you a real sense of that balance in nature, doesn't it? The interplay of toxicity and utility, defense and adaptation. The Gympie Gympie isn't just some random hazard. It's like a living library of neurochemistry.
Absolutely.
Yeah.
A very painful library, but potentially a very valuable one.
And it leaves you with this final thought. We're studying the Gympietide toxins themselves for pain relief. But what about the red-legged patamelon, the little marsupial that eats the whole plant like it's nothing? What incredible chemical superpower did evolution give it to achieve that total immunity? Could understanding the patamelon's biology be the real key? Maybe the ultimate secret to neutralizing chronic pain isn't just in the plant's venom, but in the creature that conquered it. Something to think about.